For many data sets, approximately 95% of the data lie within 2 standard deviations of the mean. This principle leads us to a rough estimation of what we would call usual values in a data set if we know the mean and the standard deviation. And if we don't know the standard deviation, we'll look at something, an estimate that we can calculate using the range. So all of this falls under what we call the range rule of thumb. So given the mean and the standard deviation for a data set, we can calculate the minimum usual value for that data set by taking the mean and subtracting 2 standard deviations. That will give us the minimum usual value. Then we can calculate the maximum usual value by going the other direction and taking that mean and adding 2 standard deviations. So as I said, sometimes we don't have the standard deviation, we just want a rough estimate of that, and there's a calculation we can use to determine that. If we have the data and we want a rough estimate of the standard deviation, we can use this calculation. The standard deviation is approximately equal to the range divided by 4. And recall that the range is just the maximum value minus the minimum value, and then we would divide by 4. So if we needed a rough estimate of the standard deviation, that's a way we could get that. So let's look at an example and see how we would use this maximum usual value and minimum usual value. So someone conducted a retrospective study. They went back in time and pulled data on the heights of male adults in 1877. The mean of the sample was 66.2 inches and the standard deviation was 2.5 inches. What would be the minimum usual value and the maximum usual value for heights of adult males in 1877? So let's see, what's the information we have here? We have the mean of the sample, which is x bar, and we're given that that's 66.2 inches, and the standard deviation of the sample, S, was 2.5 inches, and we're asked to find the minimum usual value and the maximum. We'll recall the minimum usual value was equal to the mean minus 2 standard deviations. So in this case, equal to the mean, 66.2 minus 2 times 2.5, which is 66.2 minus 5, or 61.2 inches. The maximum usual value would be equal to the mean plus 2 standard deviations. So we'd have 66.2 plus 2 times 2.5, or 66.2 plus 5, which would give us 71.2 inches. So now we know the maximum usual height of adult males in 1877 and the minimum usual height of adult males in 1877. And this could come in handy if, for example, we were asked to answer this question: would it be unusual for a male back in 1877 to have been 63 inches tall? That's 5'3". Would that be unusual? Well, now we can answer that question. 63 falls between the min usual and the max usual, so that is a usual value. It would not have been unusual for for a male to have been 63 inches because that's within our usual range. Would it have been unusual for a male in 1877 to have been 72 inches tall, which is 6 feet? Yes, that would have been unusual, because 72 inches is above our maximum usual value. So that's how this calculation can be useful to us in talking about data sets.